We have covered how to use log, ilog and ix when we use integer indexer. So here I am skipping that part and move to the next part, that is arithmetic and data alignment. As the name indicates, arithmetic and data alignment means performing arithmetic operations on Pandas series and data frame objects. And carefully handling the missing values while performing the arithmetic operations like addition, subtraction, etc. Let us create two series objects. For the series 1, I am using index A, C, D, E, and for the series 2, I am using index labels as A, C, E, F, G. Notice that series 1 and series 2 have A, C, E as the common index labels, and D is present only in series 1 and F, G are present only in series 2. When we add these two series, the internal data alignment introduces missing values in the label locations that do not overlap each other. So here D, which is present in series 1, has no overlapping label and corresponding value. Hence, this label and its value will be treated as missing in series 2. Similarly, F and G, which are present only in series 2, are treated as missing in series 1. Because of that treatment, the data alignment introduces sentinel values for those missing values. The sentinel values for missing values are nan or NA. Hence, D, F and G index labels are filled with nan values. In data frame, this type of alignment is performed on both the rows and the columns. Let us create two simple data frame objects, data frame 1 and data frame 2. The data frame 1 has 3 rows and 3 columns, and data frame 2 has 4 rows and 4 columns. For both the data frames, column labels B, C, E and row label Karnataka are non-overlapping axis labels. When we add data frames together, the result returns a data frame whose index and columns are the unions of indices of each data frame. Here I am adding the two data frames, data frame 1 and data frame 2. Notice that C in data frame 1, B and E data frame 2 are non-overlapping columns. Hence, the data alignment has introduced missing values, the nan all these elements of these non-overlapping column labels. So here we got the missing values for B column, C column, and for the E column. Similarly, for all the non-overlapping row labels, here for Karnataka, all the values are none. Suppose if we try to perform arithmetic operation on data frame objects with no column or row labels in common, the resulting data frame will contain all the null values. Let us see this by creating two simple data frame objects with data frame 3 and data frame 4. Here there is no overlapping columns or rows. Data frame 3 and data frame 4. Data frame 3 column label is A, and in data frame 4 the column label is B. In data frame 3 the row labels values are 0, 1, the values are 1, 2, the corresponding values for the data frame 4 are 3 and 4. Let us add these two. We got all the row and column labels with null values because there is no overlapping rows or columns. Let us subtract data frame 4 from data frame 3. Once again we got all the null values in the resulting data frame, row and column labels. This is because there is no overlapping rows and columns. Hence, care must be taken while working with the arithmetic operations with respect to row and column labels.